So this is our second seminar in 2021 in the SEB's Emerging Issues in Conservation seminar series, in which we feature papers recently accepted or in early view in the 3 SEB journals, those being Conservation Biology, Conservation Letters, and of course, Conservation Science and Practice. And I would like to encourage you to visit the Emerging Issues in Conservation page on the SEB website for a list of upcoming seminars, usually every Wednesday except one per month. So it's my great pleasure to introduce to you this morning, at least in South Africa morning, Dr. Igor Khorozyan from the University of Göttingen in Germany. Now, Igor began his career in the late 1990s by undertaking the very first studies on the ecology and conservation of leopards in Armenia. And then in 2002, he joined the WWF to apply his research to practical conservation while continuing with field studies. And among others, he coordinated and led projects on protected areas, large mammal monitoring, and also capacity building. Igor also taught wildlife courses at the American University of Armenia. And in 2012, he moved to the University of Göttingen in Germany as a postdoc, where he continued his teaching and extended his professional interests to human-wildlife conflict and the effectiveness of conservation interventions. Igor currently works cooperatively with the Conservation Evidence Project at Cambridge, and is an editorial board member of Frontiers in Conservation Science, as well as Zoology in the Middle East. So before I hand over to Igor, please, there will be questions at the end of Igor's presentation. So you're welcome to post those in the chat, and I will read them out, or you can ask them live at the end of the seminar too, once the floor gets open for questions. The title of Igor's presentation today is a global view on evidence-based effectiveness of interventions used to protect livestock from wild cats. So Igor, with that, over to you. You are muted, Igor.
Sorry. Thank you, Martin, for introducing me nicely, and good morning, good afternoon, good evening, everyone, for attending this seminar. So today's work is about interventions which are applied to protect livestock from different species of wildcats and how they are effective in relation to different species in particular situations in particular countries, and similar patterns. Just let me scroll down. Yes. So this is the paper. And what's the logic behind this paper? The main logic is that economic losses from livestock depredation are the main cause of conflicts. So local people, especially livestock owners, they strive to kill predators in retaliation or to prevent further conflicts. And most of these wildcat species are threatened globally or regionally, so we strive to protect them and also to ensure safe livelihoods for local people. So considering all these, it would be logical to apply most effective livestock protection interventions so that reduce losses and to reduce the motivation for local people to kill predators. So in this study, I tried to determine how effective or ineffective are different interventions in relation to particular wildcat species. And this paper was expected to become a baseline for future applications to particular feline species of interest. So before I go to the paper itself, I'd like to say a couple of words about interventions and effectiveness and why they are important at all. Generally, conservation interventions have two purposes. They either increase positive outcomes, for example, species richness or diversity, and examples of such interventions are landscape restoration, protected areas, all those interventions which are aiming to increase richness or diversity in particular case. So these interventions can be called addition-aimed interventions. And on the opposite side are interventions which decrease negative outcomes like wildlife caused damage, poaching rates, etc. So the examples are like livestock protection or law enforcement, and these interventions can be called reduction-aimed interventions. So in today's talk, I will deal just with these reduction-aimed interventions. Which are the interventions used particularly in relation to wildcats? I've taken this table just from the paper, and these interventions can be separated, split into several categories and types. The categories, they depend on the purpose of the interventions. For example, aversion training, different kinds of deterrence, acoustical, chemical, physical, visual, spiritual. They try to keep predators away from livestock. Husbandry are traditional methods of electric fences, enclosures, guarding animals, herding, or mixed applications, for example, enclosures and guarding animals at the same time. They try to protect livestock. Invasive management is a category of interventions. They deal with predators directly, so it includes handling, monitoring of predators. So they are invasive methods, which in case of wildcats, they include translocations and geofences. There are also other methods of invasive management like sterilization, but it's applied to coyotes or to other species, but not to wildcats. Lethal control are the methods which are used to reduce the numbers of predators. That's how to reduce the scales of depredation. They include shooting, trapping, and poisoning. Mixed categories, it means the simultaneous application of several categories like aversion training and invasive management at the same time. But in case of our studies with wildcats, these mixed types included the enclosures and capacity building. And non-invasive management, it doesn't deal with predators directly, and in case of wildcats, it included calving control and capacity building. So I will tell in more details about these particular methods when I consider the results of the paper. And here are several pictures which are taken directly from these wildcat papers, most of which are used in this CSP paper. This is an example of the enclosure, which is in this case called living wall. It means planting fast-growing trees along the boundaries of the bomas or kraals in Africa to provide an additional strong barrier preventing the penetration or trespassing of predators into the boma to kill livestock. And this is a very effective method. Usually bomas are protected by mesh fence or by branches, but these trees are much stronger and effective. This is a method of geofence. It works in the following way. In this case, it was with lions. Lions are put with radio collars, and the researchers collect information from these collars about lion movements. And once they cross a certain boundary, that creates a signal which is sent by SMS to researchers and to local people, so they are aware that some lions are approaching their lands. So they start preparing for encountering these lions and to push them away. This is the brand new article that we did in Iran with protective collars. This study was not included in our meta-analysis because it was published just recently. And these protective collars were fixed on free grazing.
I can hear it now. Thank you, Rabbe.
These collars were fixed on free grazing cattle in the forest of Iran, just to prevent the killing of these cattle by leopards through the throat bites. And this method was fully effective. This kind of visual deterrent is becoming more and more popular. It's called Foxlight. This is a device which is charged by solar energy and is activated during the nighttime to emit random and strong lights of different colors. And it can be also modified to be accompanied by noise. And it's expected that predators would avoid entering the areas where these lights are produced. And the last example on this slide is translocation. This is an example of tiger translocation in the Russian Far East. So why is effectiveness important? The concept of effectiveness came to conservation from the medical science. And in 1972, a seminal book called Effectiveness and Efficiency was published by an epidemiologist, Igor Khorozyan, which actually revolutionized the whole practice of medical treatments. And it strived the importance, it put an emphasis on the importance of randomized controlled trials and as a reliable method to assess, to evaluate the effectiveness of medical treatments and practices. And after that, it was a complete shift in the paradigm of medical science. At the same time, you see it on the graph, I've collected a meta-analysis just most recently about the anti-predator effectiveness studies. And approximately at the same time in the mid-70s, also similar studies on effectiveness began to appear in ecological literature, but there were no any discussions about randomized control trials or methodological improvements or meta-analysis, something like that. So those studies were generally scattered attempts in different parts of the world with different results, of course. But the first attempt to systematize this information and to bring effectiveness evaluation into a new level appeared only in the early 2000s. So it was about 30 years later than in the medical science. So you can see this lag effect in conservation compared to medicine. And still after that, you see on this graph the numbers of papers on effectiveness produced every year. It increases very sharply. So there is a dire need to systematize this information to improve the data analysis to understand what works and what doesn't in different interventions, not only in relation to wildcats or livestock protection, but also in terms of different interventions in conservation. So why do we need the effectiveness? First of all, it allows us to concentrate efforts. So we all know more or less the potential, the interventions which would be potentially effective. And we can focus on them, apply them one by one, and to see what works and what is effective, what is not, why, and so on. It takes much more focused effort in a particular site, particular situation. It also allows to select the most effective efforts and to select the best practice for future applications in other species, in other areas, and so on. What is crucially important is that these effectiveness studies allow to reduce the research implementation gap, because many people agree, and I generally agree as well, that research and practical efforts, they don't overlap much because they have different agenda, different priorities, and these effectiveness issues are an ideal candidate to befriend researchers and conservationists by producing practical information which is beneficial for all. And what is not done yet but requires deep analysis is the causal effect on effectiveness. So particularly if we apply particular conservation to particular species, for example, why is an intervention effective in this case but not effective in that case? So we need all these causal factors to understand why it's so. So because this information is highly practical, we need to make it fully open access and available for free to everyone who wants to apply them. And this can be done in several ways. The first one is through web portals. The best one is conservation evidence done by University of Cambridge, and I'm very proud and happy to be part of the teamwork on evaluation of different interventions. They have a very rich and a very diverse website about different interventions, not only about depredation, and there are different thousands of interventions. They produce their own journal called Conservation Evidence. They produce also synopses on different landscapes or species. I will tell a bit more about that later. Of course, it should be done through open access scientific publications, and just recently 2 journals were established just to promote, to provide this and spread this information. One is Conservation Science and Practice, and another one is Ecological Solutions and Evidence. And I'm proud to have publications in both of them. The third one is great literature, is greatly overlooked source of information, especially dissertations and reports, which provides also much information, which is not so obvious, but it's still very important. And of course, we know that the main language of today's science is English. So, and quite many publications are published not in English, but if they provide English summaries or some part of the text, it improves their visibility and usefulness in effectiveness analysis. So it's essential for the effectiveness to be evidence-based, not based on speculations or common beliefs or common sense. They should be based on evidence. It means that there should be special experiments carried out to check the hypothesis, whether this intervention is effective or not. And there are numbers of do's and don'ts that should be accompanied with these effectiveness studies. First of all, they require a strong study design, like randomized control trials, like before after control impact and crossover. And on the right graph, you see these designs. For example, after it just these green dots show the treatment samples, and blues are control samples. The after design, it just takes the treatment after without comparing with anything. So generally, we cannot say whether it's effective or not. Before after, it means measuring something. In this simulation study, it was just density of some species, which was expected to increase with interventions. It's just comparison of this density before and after. Again, there is no control. With BACI, control is used, and also the samples of both control and impact are compared before and after, which allows robust estimation of effectiveness. And this method is particularly effective with protected areas where random sampling is not possible. Control impact analysis is a comparison of with and without interventions, which is also without controls. Here it shows some control samples, but actually they are pseudo control, because, for example, if we compare villages with dogs and without dogs, those without dogs cannot be a proper control, because maybe they are different, they are located in different places, they have different precipitation, different landscapes and other factors. So these differences can be caused not essentially by interventions, but by other factors. And one of the best methods is the randomized control trial, which uses properly random sampling. They originally take one sample and split it into random control and treatment samples, and analyze how the intervention works. And on this small graph table, you see this crossover design, which is a very interesting study design when each unit is the control and treatment at the same time. So you see, for example, in the first 6, there are 11 farms, and the first 6 of them, they are used as treatment in the first period, but control in the second period. And the other 5 farms are opposite. They are control in the first period and treatment in the second one. So it allows to analyze information in the most complete way. which are the don'ts in the effectiveness analysis is that they should not be a haphazard try and see effort trying to manipulate and to see how it works. It should be properly designed. And I forgot to tell what is also important in do's of effectiveness is that it should be based also on proper statistical analysis of comparison of treatment and control samples, and also use reliable metrics of effectiveness like relative risk, odds ratio, and so on, which are also taken from the medical science, and particularly relative risk and odds ratios are very popular in medical literature. Also, what should not be done in effectiveness is to apply this before, after, and control impact designs which do not use proper control samples. Another thing which is not recommended is to use surrogate metrics, which do not estimate effectiveness directly. For example, perceived effectiveness. It's very important in social science in understanding the social issues underlying conflicts with wildlife, but they do not essentially reflect the levels of, for example, livestock losses, because human perceptions are affected by many other factors, not directly by livestock losses or other factors. So these surrogates should not be used. So why is it important to use the meta-analysis? First of all, meta-analysis can be a guide for us to find solutions because they generally compare information from different sources. They apply the most possible comprehensive literature search. They standardize the methods of literature search, collection, analysis, and presentation. When doing meta-analysis and striving to collect as much as possible information, we have a trade-off. Whether we select only for the best quality data, but in this case, we tremendously reduce the sample size, or we relieve our demands, requirements for study design, but in this case, we increase the sample size. This is very important because all the studies, they generally applied these less reliable designs like before, after, or with, without, and we cannot simply ignore them. This is actually what I did also in my meta-analysis. I collected as much and used as much as possible information without paying much attention to study design. Also, meta-analysis provide much needed statistical comparisons between sites, between species, between interventions, and they serve as a baseline for replications from where practitioners and the researchers can pick up particular intervention and try to apply in their situation. What was also one of the main motivations for me to apply this meta-analysis is that it saves much time for researchers and practitioners in searching additional literature. So it serves as a source of information which always can be referred to without a need for searching for the literature again and again. And such meta-analyses, they began to be published very rapidly, starting from 2016. And here I just show them from the earliest to the latest. There are 8. So if we have 8 meta-analyses, what else do we wish to do? First of all, we need taxonomically focused meta-analysis because taxonomic focus makes interventions much more relevant to particular situations, particular scenarios. And you see on the graph on the right side, along with bioclimatic factors and metrics of effectiveness, taxonomic focus makes these applications much more relevant and right to the point. This taxonomic meta-analysis also may uncover information which is taxon specific, which can be generally ignored or missed during the general meta-analysis. For example, the journal Orsis, which is completely dedicated to bear species, or the library of the IOC and cat specialist group, which is dedicated to wild cat species. These are very, very valuable resources of information for the meta-analysis. And again, we need to find a compromise between the quality of data and sample size, which I told before. And I and my team members already published 3 papers about the taxonomically focused meta-analysis. One is about the effectiveness of interventions against wolves. One is against bear species, different bear species, and this one against wild cats. So let's return to this paper. I collected data from the meta-analysis which were published before, which I've shown on the previous slide. I used all issues of the journal Conservation Evidence, all issues of the Carnivore Damage Prevention News, which is a very nice newsletter dedicated to wolves, brown bears, and lynx in Europe. Cat News published by the IUCN Cat Specialist Group. I also used the library of that group and the Human-Wildlife Conflict Task Force. I searched the literature through the Web of Science and ended this search in late October 2019. And out of the literature that I found, I included only those studies which were related directly to livestock protection interventions against wild cats. But there were several criteria that I excluded the literature, and there were correlation analysis. Correlation analysis, it can show the trend. For example, the more dogs we use, the less depredation is, but it shows the trend, but doesn't show the comparison between treatment and control samples. And even if the study design is proper, this information is usually not provided in the paper. I excluded papers with captive animals and excluded the papers which combined felid and non-felid species like wildcat species and jackals in South Africa, because it was impossible to disentangle this effect for particular species. But still, I considered the papers which combined several felid species like jaguars and pumas in Mexico. I excluded studies with perceived effectiveness because, as I explained before, they do not essentially accurately reflect true losses, and also excluded the papers which didn't have sufficient information to calculate the metrics of effectiveness that I will show on the next slides. A couple of words about the mammal synopsis, which was recently published by Conservation Evidence. This is a fantastic source of information, and I highly recommend it to everyone working with interventions and their effectiveness in relation to mammals. It excludes bats and primates because their synopses were published before. Unfortunately, I didn't have a chance to use this source for my meta-analysis because we worked simultaneously in the same period of time independently, so it was not published when I worked on it. But when preparing this presentation, I just compared the literature that was available to me in the paper and in this mammal synopsis, and you see that 19 papers were available in both synopsis and my paper. 38 were just in my paper and 11 were in synopsis alone. So you see that the overlap is quite low, but I need to stress that I compared only interventions related to livestock depredation, even though but this synopsis contains thousands of different interventions, not only related to depredation. So this is the metric of effectiveness that I used. It's a relative risk of damage, which is the probability of damage in treatment samples divided by the probability of damage in control sample. And based on this relative risk, I calculated the percentage of damage reduction. And in reduction aimed interventions, the effective interventions are those having the relative risk less than 1. And when the relative risk is equal to 1, it means ineffective. So the percentage of damage reduction is 0. And the cases with higher than 1 are counter-effective. So they increase damage instead of decreasing. So this is the sample that I used in my wildcat paper. You see that the larger samples were collected for leopard, lion, and puma, and on 4 interventions, which were deterrence, enclosures, guardian animals, and translocation. And in general, there were 92 cases from 57 publications. The results show that the effectiveness of interventions differed between species, not so much between interventions, but they differed between species. And I've produced this heat map showing the pairs of species. It looks like a correlation matrix. And in these green and orange cells, which show the significant difference or marginal difference between the species, the column species, the effectiveness in column species is higher than the effectiveness in row species. For example, in this case, you possibly don't see my pointer. Oops, sorry. Yes, if you see it, for example, here, effectiveness in cheetah is marginally more significant, higher than in caracal, or in this case, effectiveness in cheetah is significantly different from leopard, lion, and puma. And then I divided these species, in total there were 10 species of wildcats, and I divided them into 3 categories. One is the species which in which effectiveness was high. There were cheetah, Iberians, lynx, and snow leopard, in which the damage reduction, the percentage of damage reduction was 70 to 100%. And in case of cheetah, the interventions were translocation guardian dogs enclosures. In Iberian lynx, there were electric fences and enclosures. And in snow leopard, there were enclosures and capacity building. So they were mixed, simultaneously used. Capacity building of insurance program, and covering of enclosure halls with metal netting to prevent the entrance of snow leopards into the enclosures to prevent the killing of livestock there. The second category of species where there's that the effectiveness was generally high, but some interventions were ineffective. For example, in case of Eurasian lynx hunting, these interventions are marked by red. They show a very variable effect. For example, in Eurasian lynx, hunting was not effective because killed individuals were easily replaced by new immigrants from other areas, and then they resumed killing livestock. And also the costs of hunting was very high because economic losses from lynx predation are quite low, but the costs for hunting these lynx are very high. So it's disproportionate difference between costs. In case of lynx, there were also electric fences, herding, guarding dogs used, and they were generally effective. For jaguars, researchers used translocation guarding donkeys and enclosures in the same study, guarding cattle breeds like Creole cattle, enclosures, electric fences, and capacity building with compensation. And in several applications, electric fences were effective against jaguars, but in one application it was not effective because the area, the farm, was not completely fenced off, so jaguars found a way to enter the farm through the areas which were not fenced. And for comparison, in this study in Mexico, where both jaguar and puma were used in the same study, they were effectively pushed away by deterrence. For lions, they used translocation geofenced enclosures, deterrence, capacity building with compensation. And in case of deterrence, one deterrent was ineffective. It was a bell put on the neck of cattle, because it was a hypothesis that lions would be frightened by the sound of bell on cattle, but actually they were attracted and they killed more cattle with bells because they associated the sound of bell with easy prey. So the result was counterproductive. And compensation program didn't work with lions, just in generally it worked, but in some cases it didn't work when they didn't consider carefully the social standards and social and the local traditions and customs in Aboriginal people. In case of tiger, they used translocation, deterrence, capacity building with compensation, but some deterrents, they worked and some didn't. So in this case, it remains, the question that remains open, whether it was related to individual animals or to study areas, so it was not so clear. And for 3 species, generally interventions were ineffective. There are caracal, leopard, and puma, because these species are generally most common and most tolerant to human presence, and they are very frequently occurring in human-dominated landscapes, so they are possibly best adapted to interventions, and they are familiar with these human activities, and they are not frightened or pushed away by interventions. In case of caracal, there were only guardian dogs in Southern Africa, and the effectiveness was not so high, it was moderate. In case of leopard, all interventions that were used, some of them were effective, some of them were not effective, and the most ineffective was just in one study in Iran with herders, with shepherds. We found out that the sheep and goats that were accompanied by shepherds, they incurred actually much higher losses to leopards than those which were not accompanied by shepherds. Possibly shepherds and their dogs provoked leopards for more attacks by throwing stones, the crying, and dogs also provoked leopards for attacks. So the result was counterproductive. In case of pumas, hunting was not effective because as in case with lynx, these killed individuals were easily replaced by newcomers. Llamas were effective against coyotes and other canids, but not against pumas. Enclosures and deterrents also show different levels of effectiveness, and they are generally ineffective in those areas, suburban or agricultural areas which are human dominated, and pumas are well adapted to human activities. So here we can summarize what makes interventions effective. In case of capacity building, these interventions should be locally friendly and include compliant management, compliant to local traditions and customs. And also programs like compensation, they should promote the use of interventions. So they should motivate local people to apply interventions, otherwise they wouldn't get compensation. Translocations are generally very risky, and risk analysis and mitigation should be well thought before translocations are initiated. And the places where animals are to be released, they should contain low densities of species and humans to minimize future conflicts. And it's crucially important to standardize the protocols of interventions. In case of geofence, this is a new study, just one that I am aware of. And this study would be ideal to collar all lions, for example, or other animals present in the area. So locals and researchers would be aware of the presence of each individual, but in practice, this is unrealistic in many situations. It would be very expensive, especially in the areas where predators are many. Guardian dogs, they must be properly trained and cared, otherwise they just raise alarm and act as acoustical deterrent, but they don't help to prevent losses, and only best individuals should be used. Llama, alpaca, and donkeys are also sometimes used as guardian animals, and they require much less care than dogs and much cheaper. But they're generally more effective against wolves, coyotes than against felids. And it's not clear how they work with cattle. They generally work well with sheep and goats, those livestock which live in compact groups, but with cattle it's not possible. And like with dogs, there should be only best individuals used. Buffaloes are quite practical now in Latin America, and they also can be used, for example, in South Asia, but they need wet habitats to live in. Herding is like with dogs. If shepherds don't show proper protective behavior, their presence does not keep predators away. So shepherds should demonstrate proper protective behavior against predators. Enclosures become effective when they use proper materials and when they are maintained regularly. and when they address predator behavior. For example, certain types of or enclosures are very strong against lions, but not strong against leopards, because leopards are very skilled in climbing, so they can enter the boma, for example, while the lions cannot. Electric fences are very common, especially in Europe and North America, but apparently they are feasible only in small areas, and they require regular monitoring and maintenance to ensure electric conductivity in the structures. Acoustical, visual, and other deterrents, it's not yet clear whether they are affected by the species, site characteristics, or it depends on individual variation between individuals of predators. And generally, the effects of these, especially of acoustical and visual deterrents, they are short-term, and this is particularly striking in human-dominated landscapes where predators are well aware of human presence, and they are always well adapted to novelties like to light and sounds, so they are not kept away by deterrents. That's why deterrence should be used in a very flexible way to keep predators alert. And it's recommended to apply these deterrents only during the short periods of peak depredation, for example, during the breeding season, when livestock losses are particularly high. Lethal control is generally not effective, or if effective, this effect is very short term, because new individuals come and generally they resume livestock killing. Selective removal of those individuals that kill livestock is particularly effective, but it's very costly. I also tried to validate my database using my previous paper with this scheme, where we found that it's most effective to apply physical deterrence, electric fences, guardian animals, and coving control to livestock to protect them from cheetah, Eurasian lynx, gray wolf, and lion. So here we have 3 felid species, and we tried to find the literature which was not included in the original meta-analysis trying to validate on an independent sample. And we found several papers where we found that indeed the percentage of damage reduction was 100% for guardian dogs against Eurasian lynx and cheetah. So it shows that this framework can be useful for future applications. What is a very important result of our paper is that almost quarter of all the papers were gray literature, which I obtained from Cat News, from Cat Specialist Group Library, and from Carnivore Damage Prevention News, and a few papers were obtained from the previous meta-analysis. It all shows that gray literature should not be overlooked, and much effort should be dedicated to finding it and analyzing it. But it's very important to know that, particularly with this, with the case of dissertations, the same information can be present also in scientific publications, which is based on dissertations. So it would be an autocorrelation of information in dissertations and scientific papers. So it should be carefully analyzed whether it's the same information in the paper or dissertation, or they are different. So if they are autocorrelated, one of them should be excluded from the analysis. So our study had several limitations, but they also open up new pathways for future improvements and future applications. We had small sample size per species. It means that we need to apply more interventions for each species and for several species at the same time to compare them. There was an unavoidable geographical bias because many areas are not covered in intervention studies, and I recommend to apply interventions to lion in West or Central Africa and in India, to cheetah in West and North Africa and in Iran, tiger outside of the Russian Far East, Eurasian lynx in Asia, snow leopard in Mongolia, China, and Central Asian republics, and caracal throughout its range in Asia and Africa. I didn't use the analysis of habitats, individual behavior, body mass, and other variables, and it was one of the criticisms of the reviewers of the paper when it was considered for publication. And I explained that it's premature now to use this kind of meta-analysis because there are different scales, and For example, landscapes are usually studied in large scales, but the intervention effectiveness studies are very fine scales. So we need to standardize these studies and conduct local fine scale studies to create a data set, which would be later used for future meta-analysis. So here is a list of references that I used for this presentation, and thank you very much.
Thank you very much, Igor. I have not seen any questions being posted in the chat. There were a couple of comments, but maybe before we look at that, I think I missed it while I was letting somebody in the waiting room. I had a question specifically to the tigers, and I think it was related to deterrence, where it was actually counterproductive. What kind of deterrents were those that actually increased depredation of livestock?
These deterrents were used in the Russian forest, and generally there were shots in the air. There were small rockets, projectiles, and sounds, stones, these kinds of pushing tigers away. But they came back quite fast. And it's always the case in deterrent studies, not only with tigers, but with different other species, especially in human-dominated landscapes. They just return very fast. And this is a notorious case with bears, which are real nuisance.
Okay, because I see somebody made a comment in the chat about in Zimbabwe using vuvuzelas to keep lions away.
What is vuvuzela?
How do you describe?
I'm sorry.
How do you describe a vuvuzela? Almost like a plastic trumpet, a bugle.
Oh, okay.
That just makes
horn, like horn.
Yeah, like a horn that just makes a very loud noise. But you'd think that is very sort of labor-intensive means of doing it.
I read about that on the internet, but I didn't find scientific literature about that.
Okay. Then I've got a question here from Louise Swemmer, who says, thank you for the presentation. Would you mind reflecting a bit on the trade-offs over and above less predation? So maybe certain methods are more effective but cost more, etc.
Yes, generally more effective are electric fences, but there are everything goes into practicality of particular use of intervention in a particular site. For example, we like electric fences, which are generally effective in North America and Europe, but we cannot apply them in Africa or in the Himalayas with snow leopards just because people don't have electricity. So here is a trade-off between effectiveness and affordability. That's a serious question, actually, that we need to analyze carefully for each analysis. And the meta-analysis on this topic would be highly welcome.
Because, of course, in most of the, certainly in most rural areas in Africa where people have to protect livestock from depredation, there's potential.
And everything goes also to the maintenance. So it's not enough to apply project and to apply the intervention, because we generally don't know the project is over, but we don't know how it continues to work after the project. So it depends on how the intervention, or how the households, for example, cared and maintained after the project.
I had a question for you about herders. You said that the herders need to display proper protective behavior. And in the comments, there was a comment from Bull Smuts, who works in the Karoo in South Africa, that says through herding, they've eliminated depredation 100%. So from what you've done and what you've read in preparing for this paper, what is proper herding behavior?
For example, in Iran, where they were highly ineffective, shepherds are not allowed to carry firearms. So at least they could shoot in the air and to push the leopards away somehow. It's prohibited, of course, to shoot leopards directly, but they could shoot in the air and not to make so much noise as they did in Iran, because it can be counterproductive. And generally with shepherds, the best way is to keep them alert, to keep good dogs, essentially good dogs, not just any dog, but good dogs. That helps much. And an ability of shepherds to control the whole flock. For example, in the mountains, herding is generally ineffective because they lose control. They cannot track every animal in the flock. And when they go behind the mountain, they're just easily killed by a predator. So ideally, it would work in a plain area where all livestock are well visible.
Okay, then I have another one from Louise Fenner, who asks if you can maybe also reflect a bit on compensation. She says possibly what's also important is the reason for the intervention. So some may be less effective but serve other purposes, such as compensation, which may be about historical redress, probably more than it is about the value of the actual cow that was taken by the predator.
So you mean how to pay compensations and also to motivate to use interventions?
Maybe, yeah, if you can just reflect generally on a comment or on compensation.
Yes, the main problem with compensation is that it doesn't motivate people to use interventions because they get guaranteed money and they expect it every time they lose their livestock. So it can create a vicious circle. Another problem is that compensation also needs secured long-term funding, which is generally not available in many places of the world. And it creates a kind of bureaucracy. People lose their livestock, they expect compensation, but it takes months and they take only part of that payment, so they don't rely. And for example, in case of Iran, where I carry out many projects, people don't even inform the government about losses of their livestock because they don't expect anything from them, even though they suffer economic losses. So it's a very political tool, you know. It's very hard to explain it just in terms of livestock losses and motivation to use, but it's very political and administrative tool, which is very complex, and I personally do not like it.
Okay, thank you. Then I have a question from Cindy Stadler, who asks, have you come across any research that deters African wildcats or similar sized species of cat from predation on sheep lambs? My study in the Kalahari, South Africa, indicates that wildcats are the top predator by far of newborn lambs, as caracal and jackal numbers are low. Farms are very big, and the current legal methods of control are not practical.
The most intensely used intervention there in Namibia is guarding dogs. But the publications about their effectiveness, they are by Gail Potgieter, now Gail Thompson. But also the effectiveness of guarding dogs depends on sites and depends on local cultures on how to care and how to train dogs.
Okay. So a potential way forward in the Kalahari would be guarding dogs.
Yeah, apparently, yes.
I then have another question, and I mean, I don't know if most of your work has been on felids as such, but you made a comment that lethal control is not effective for felids. And I was wondering, is it actually effective for any carnivore, as far as you know from everything you've done?
Which intervention, sorry?
Lethal.
Yes.
Because in some parts of the world, it is almost the go-to method. So are people just barking up the wrong tree by doing that for any kind of carnivore, or is your comment more specifically related to felids?
Here I commented it more in relation to wild felids, but also we analyzed it for bears and wolves, and generally it's not effective because they are replaced by new coming individuals, and it's very also like compensation, it's a very political issue. Lethal control is generally not favored by general public, and the most effective one, which is selective use of culprit individuals, it's very hard to apply in practice.
Okay. Then I have a question from Bull Snuts, who says, like herders, compensation, guarding dogs, fencing, and kraling is varied in application. And I'm concerned that lumping them all together in the categories loses some nuance. To what extent did your analysis account for that?
This categorization was just for convenience, because assuming that they differed in the ways of applications. So generally husbandry, it contains, yes, enclosures, guarding dogs, but they all include the traditional methods which are traditionally used for centuries and millennia by people. So it would be logical to combine them into the same category of husbandry, especially because in many cases they are applied simultaneously.
Okay, then I've got one more that came in from Mohammed Faradinia, who says, thanks, Igor. How is your work related to problem individuals, which usually commits conflict disproportionately? I presume most interventions are population level, but conflict can be caused mainly by a few problem individuals. What do you recommend for these individuals?
That's right. It also includes those cases of selective hunting. Usually it's in the literature that I found, it was mostly about selective removal of these problem individuals. I also tried to address this issue in a different analysis, and I found out that this is not much about problem individuals, but problem sex, which is males, just because they range widely over large areas and they have higher chances to find and kill livestock. And also it's more about inappropriate places where to graze livestock. So it's not so much related to particular individuals, but to the chances of predators to find livestock and kill them. Although, of course, in some situations, problem individuals occur.
Yeah.
But it's not a general pattern.
Okay, I've got one more from Sarabian Cecile. It says, thanks for the talk. What about deterrence methods based on adaptive systems rather than solely on anthropogenic needs? Example, olfactory cues that trigger the behavioral immune system of carnivores and which could then be applied at strategic locations to deter them from depredation.
With deterrence, nothing is actually clear for sure because as I also mentioned, it's not clear whether it depends on generally on local conditions or individuals, because individual animals also differ in their responses. And the biggest problem also with deterrence is that there are no deterrents, especially acoustical and visual ones, that deter for a quite long time. So these individuals, they return to the same area after very quickly, maybe on the same day. So generally, yes, there are methods which also can be recommended to people like tourists or to those who hike in parks or in urban areas. But there are just quick solutions which don't solve the problem.
Okay, and then maybe one last one as we have come to the end of our scheduled hour. And this one is from Maria Petridou, who says, thank you, Igor, for the very informative presentation. What is your opinion on state funding of preventative measures?
It depends on countries. For example, in Europe, the state funding is secured in case of electric fences, but it depends on the welfare and economic prospects of the countries. With this corona situation, for example, we wouldn't expect secure state funding for this because there are many more other priorities to spend. But the problem with state funding is the same as with compensation. It's guaranteed money that make people relaxed. And this is quite a situation that needs careful attention. So we always need not to rely fully on state support, but also to find alternative sources of funding. And also maybe in wealthy countries like in Europe, maybe some partial funding from the owners themselves to keep them responsible for the effort.
Okay. Thank you very much, Igor. Thanks for
Thank you.
a very informative seminar and quite a useful discussion at the end. I would then just like to remind everybody that next Wednesday on the 17th of February, there will be a presentation or seminar by Matthew Luskin from the University of Queensland. And the title of that is Will the Onslaught of African Swine Fever, which threatens 10 endemic Southeast Asian pig species, trigger trophic cascades in tropical forests. So that is then next Wednesday. You can see the schedule on the SEB webpage for all future seminars. With that, thank you very much. Thank you, Igor.
Thank you very much.
And hopefully I'll see some of you next Wednesday.
Sure. Bye.
Thanks.